exciting episode here at IT Pro TV. I'm your host, Wes Bryan, and in today's episode, we're continuing through our series inside of VMware. That's right, we're coming back with more of the VMware Certified Professional version 6. Joining me back in the studios is none other than Mr. Don Pizzette. Don, how you doing, sir?
I'm doing great, Wes. Ready to dive right back into vSphere 6, and in this episode, we're going to be tackling data stores. You might have noticed something kind of interesting at this point is we are, I don't know, we're a solid 10 episodes into this series or something like that, and we haven't created a single virtual machine yet. This whole thing is a virtualization product. We just haven't created virtual machines. And there's a reason for that. There's a reason for all this stuff, is that it is really important that we get our infrastructure set up correctly first before we start slapping VMs into it. Otherwise, they're not going to perform well. And one of the main areas that we haven't addressed yet is the data store. And the data store is simply a place on the hard drives where we put our virtual machines hard drives. Our virtual machines have virtual disks, and those virtual disks have to go somewhere. Now, if you have a default install like I've got, what I've been working with this whole series, the only place you could put your virtual machine's disks are on the same drives as the ESXi operating system, and that's not ideal. We don't want to do that. So we're normally going to come along and create our own data stores where we can place the disks. And once that's done, now we'll have the network in place, the disk in place, the hosts in place, vCenters in place, and it's ready to create our guests and actually get to virtualizing. But before we get to that, let's take a look at the data stores and see what we can do. In our last episode, we talked about some of the different storage types inside of ESX and vCenter in general. And so in this episode, we're going to actually use them. So instead of just talking about how they work, we'll actually put them in play and start to get our system set up. Now, I want to start off with the most common type of storage, which is also the least flexible, and that's direct attached storage. If you have an ESXi box, the easiest way to get it up and running with storage is to stick a hard drive in it, right? You probably already have a hard drive in it for the operating system, so you can stick more hard drives in it to have additional storage space for your virtual machines. Now, we can do that and it'll work just fine, but it kills certain things like vMotion. If I have a virtual machine that I want to be able to fail over from one physical host to another physical host, the storage needs to be able to move along with it. And having a SAN, a storage area network, provides that. Now we can have it where we fail over and the storage follows the VM over to new hardware. But with direct attached storage, you don't have that. So direct attached storage is easy, it's cheap, but it's not flexible and it's not resilient. So in the event of a failure, your systems will go offline. And you might have a RAID 5 or RAID 10 array or whatever, so you're not going to lose your data, but your data is still offline during that failure. So you've got to recover and bring it back on. But it is the simplest, so let's kind of start right there. Now, when you install ESX, it actually creates one data store for you. If you poke around in your storage, you'll see them pop up. Now, in my environment, if I go under my hosts and clusters, you'll see I've got two hosts, host 01 and host 02. I've got host 02 in maintenance mode right now. But here's my two hosts. And all I did was install ESXi on them and add them into vCenter. That's it, right? I haven't really customized them at all aside from that activity. Now, if I take ESX host 01 and I go over here to related objects, I can see the other things that are attached to ESX host 01. So you'll see things like virtual machines and virtual apps and so on. And if I keep scrolling over, I can find data stores. Now, I didn't create a data store for ESX host 01. It created one for me. And so I see it right there, data store 1. And data store 1 is direct attached storage. It's on the hard drive with the ESXi operating system. All right, so that's shared with the OS. Now, I say it's direct attached. There is one scenario where it might not be direct attached. If I have a fiber channel SAN and I have a fiber channel HBA in that host, then it can't tell the difference between an internal hard drive and one that's over fiber channel. The fiber channel one looks like an internal drive. So potentially this could be on a fiber channel array, but I know that server, I'm the one who made it, and it's got a very small hard drive for the operating system, and that's where this data store is. So the data store is not particularly big. Now, one problem you got to watch out for is the name. See how it's called data store 1? And if I look at ESX host 02, which is offline for me right now, it's called data store 1 also. Well, it is parentheses 1, which meant there was already one data store called data store 1, so they call this one data store 1, right? Every ESX host that I bring up is going to have this data store 1. And I'm going to end up with a bunch of them. And it gets annoying, especially if you go if you go to Home and Storage, and you start to see a list of all your data stores. And so when you look at your data stores here, they start showing up as data store 1, data store 1, data store 1, over and over and over again. how do you know which one is which? Which one of these belongs to ESX host 01, which one belongs to host 02, and it gets confusing, right? So I like to rename these to be able to keep it all straight. But if you're ever curious, if you just don't know which server it belongs to, that's where that related objects tab comes in really handy, is that I can choose Datastore 1 or Datastore 11, and when I go to related objects, that's where I can find virtual machines as well as hosts that are attached to it. And now I can figure out who that's attached to. But I'm just going to rename, like I'll take Datastore 1, and I'm going to rename that. So if you right click on it, you can go down here to rename, and I can rename it something else, right? So I'm going to call this one ESX host 01-Datastore 1. And that way, now when I look at it, I don't have to pull up related objects. I'll know exactly where that data store belongs. It's right there, and it's on that system, and I can tell it apart. And I'd probably do the same thing with this one. I don't know if it'll let me rename it while it's offline. It might. But if I can rename it while it's offline, then I will. There we go. Now, I'm making a change while it's offline, and what's going to happen is it's just going to kind of queue up this change, and the next time that server is back online, it'll update it. But right now, it's putting it into the vCenter database, and so the next time that host is online, it checks the database, it sees the change, and it takes it in. So it let me make that change while I was offline. All right, so now I've got those named, and I can tell them apart. Naming your data stores is really important. And your end users, they never see this name. In fact, most people never see the name, even administrators. We see it when we create a new virtual machine and we have to pick a data store. So giving it a name that's meaningful will really save you a lot of time. All right, now in that host, in either of my hosts, I actually have more than one hard drive. So if I take a look at ESX host 01, and I'm going to go into Manage and Storage. So I'm just browsing into Host and Clusters, browsing into ESX host 01, going to the Manage tab, going to the Storage button. And then down here, I can see my storage adapters and storage devices. And under storage devices, I'll see all of the storage that I've got. And right now, I've got a 40 gig hard drive and a 500 gig hard drive inside of that system. Now, I show them as hard drives. They could be a RAID array, right? This could actually be 5 hard drives in a RAID 5 array. I wouldn't know, because VMware is going to see it as a drive. I'd have to go to my RAID controller to see how that's actually configured. But as far as ESX is concerned, this is just a 500 gig hard drive. Same thing with the 40 gig here. It doesn't know exactly the information about that. Now, for the most part, it'll detect these drives, and we can start to work with them. My data center that I made, or my data store 1 that was automatic, was created right here on this 40 gig drive, because when I did the install asked me where I wanted to install, and I picked this 40 gig drive. And so it created data store 1 there. If I had checked both of these drives during the install, then it would have made Datastore 1 span the 2 drives. But I'm not a big fan of that. The reason is, if you lose either drive, the whole data store is gone. You have to have both intact. So I don't like to span data stores across physical drives. I usually use a RAID controller for that. That's the better way to handle it, or use your SAN, it'll handle it. But what I did is, when I did the install, I just chose the 40 gig drive, and I left this other one empty. So this one is empty, it's sitting there, it's not being used, and I can now go and create a data store on it. Now, let me double back on spanning hard drives. When you create a data store, it can span more than one disk. And if it does, some interesting things can happen. Normally, we don't want to do it. We use a RAID controller. But there's one scenario where we might want to go ahead and do it. And that's where I want to mix SSD and regular magnetic disks, right? So magnetic disks, those are the ones that have the spinning platters inside of them. They got a motor and an arm, and they can only go so fast. But SSDs are solid state. They go really fast, right? And so it's much faster storage, but it's much more expensive. So we can't normally buy as much solid state storage as we do magnetic. So we might want to mix and have what's called tiered storage, right? Tiered storage is where you have super fast, super expensive storage, and then you have slower, cheaper storage. And you normally have a little bit of the fast stuff and a lot of the slow stuff. And so there may be critical things that you want to go on the fast storage, and things that are very infrequently used to go on the slow storage. Well, if I make a data store that spans both SSDs and hard drives, then ESX will actually prioritize that for me. It'll take the frequently accessed stuff data and move it to the SSD, and it'll take the less frequently accessed stuff and move it to the magnetic media. So it can do that if it knows what disks are what. And when I look at this, notice how I've got these 2 disks here. One's 40 gigs, one's 512, and see how the drive type shows as flash on both of them? It thinks they're both solid state disks. Now, I don't know why it thinks they're solid state disks. I know, and they're spinning disks, right? So they're not actually solid state. So I may need to change that. And you can highlight a disk and see this little button up here that says HDD. If my disk was misidentified, I can click that HDD button and it'll convert it from flash to magnetic. And I say convert it, it just makes a little note in the database, and that's it, right? So it's not spectacular. It's not having to move files or anything. It just changes a little note, and it's done. And eventually, it'll show up. Again, if we get impatient, we can always refresh. Oh, there it goes. Sorry, I'm being impatient. So now it just shows as a regular HDD, right? And so if I have disks that are flash, and I have disks that are regular magnetic disks, I just need to come in here and make sure they're flagged properly, right? And so now that one is flagged as HDD. Didn't matter here because I'm not going to span the disks anyway, but if I was spanning, it'd be really important for me to go in and flag these right. And if it was an HDD, if it was a regular magnetic disk, and I wanted it to be solid state, now I could highlight it, and you'll see the HDD button change to an F button for flash. And now I can flag it as SSD, and that way VMware will know the difference. It'll be able to make the decision as to how it prioritizes that data. All right, but let's say I want to actually use this 500 gig disk now. I want to put a data store there so I can start creating virtual machines and other things. Well, I need to go to my host, and I'm just going to right-click on the host, and in the menu that pops up, I'm going to look for the storage menu, and under storage, we're going to go to New Data Store. You'll see there's a few other options here like rescan storage. If I had a hard drive go offline and I repaired it, I'd need to rescan storage so it could spot the new disks. Or if I have hot swap bays, a lot of servers do, and I add disks, I could rescan storage and it'll find those new disks, right? So that's what that option's for. And then add virtual flash resource capacity. What's that? Well, with our systems, you can throw in an SSD drive and have it be used as a cache for the system to accelerate, again, frequently read stuff, like tiered storage again. Except this isn't necessarily dedicated to one particular data store. It can be shared for that host itself. And so I can add some flash storage to serve that role. And you're starting to see some servers that come with a little, it's an mSATA port right on the server's motherboard, where you can pop in a 128 or 256 gig card and have that accelerated cache right there. But I just want a regular old data store. I want to put some information on this drive. And so when I go to create that data store, it's going to give me three choices. All right. I can create a virtual machine file system, or VMFS. When you're adding storage to a local disk or to a LUN, right, a logical unit number, which would be if we were attached to a SAN, then we're going to create a VMFS disk, right? And we're going to talk about these other ones a little bit later, but NFS is if it's network storage, and a vVol, or virtual volume, is if we're attached to a virtual SAN, and we're creating a virtual disk on it, right? But I'm going to create a VMFS, a virtual machine file system. That's almost always what you're going to do. And then on the next screen, now it's going to show me any disks that are not currently used. And right here, I can see that 500 gig disk that is not in use. I don't see my 40 gig disk. Why not? It's in use. It's already got a data store on it, so it's not going to show up here. I just see my 500 gig disk. Notice the name. I'm guilty of this really bad. I think I did it in an earlier episode. I'll just hit next and leave it called data store, and then you get confused which one is which. So I like to rename it, and I'm going to name this one, I'll just call it ESX host 01 dash, I'll call this DAS data store. So this is going to be my direct attached storage data store. So just giving it a name so I can remember what it is. And I'm prefixing it with a server's name to make it easier when I'm in vCenter and I see a ton of servers. If this were a standalone server, I wouldn't do that. I wouldn't care. But in vCenter, it does get confusing sometimes with all the different data stores that are out there. So I'm going to name it appropriately. And then I'll highlight that disk. If I have more disks, I can choose them. If I have multiple disks, I can do that too. And then I'll hit next. Then it's going to offer to partition it. Now, back in the day, we used to partition disks all the time because it seemed like a good idea. But in this day and age, partitioning disks is not really useful. If you're attached to a SAN, then on the SAN, you're slicing up disks there, and you create the slices to be the size that you want. You don't need partitions. On a RAID controller, you can do the same thing. You can slice up your disks in the RAID controller, and you create the virtual disks that map to what you want. You don't need partitions. But it doesn't mean we don't still have the option. So if this were a true single disk and I wanted to divide it in half, maybe half was going to be a data store for a certain set of virtual machines and the other half was a data store for another set of virtual machines. I could do that, right? And create it in that empty space and go. But the reality is that every virtual machine is going to be isolated from each other. So even though they have storage in the same data store, they can't see each other. So there's not really any reason to create partitions. There's no performance gain. There's no security gain. It's just organization, I guess. If you want to organize things, you can do that. And so over here, if I start to adjust my size, see how that partition is shrinking or growing? So I can change that, and then I could use this empty space to create another data store if I wanted. Or I could leave it empty. Maybe I just don't care. I want to waste some storage. I'm going to go ahead and crank it all the way up. All right? And the default option here is to use all available partitions, but you can tweak that if there were existing partitions and just grab one particular partition. I don't have any, so it's blank for me. All right, so I'm going to go ahead and choose that, and we'll hit next, and we'll finish that up. Notice I am running vSphere 6, and this is ESXi 6, but the file system is VMFS 5. Okay, it's actually, if I remember right, it's like 5.61 is what the actual numbering is, but it's VMS version 5, which is the same as what we used under ESX5 and ESX55, right? So there's not really been any giant increase in features or improvement there, so it's still VMFS 5. All right. When I finish, it's going to create a new data store, so it's building that in the background, and it looks like I might have had a little bit of a problem. So it created the VMFS store, and I see that that's completed, and under rescan VMFS, I got unable to communicate. Well, that's for host 02. Host 02 is offline, so I can ignore that one. It tried to rescan the file system for multiple servers. Now, why would it do that? Well, I just created a standalone data store, but we can create distributed data stores. Distributed storage is spread across more than one machine, and when you do that, it would need to scan multiple systems. So anyhow, I tried to scan the other system. I'll just ignore that. All right, so now I've got a nice new shiny data store, and if I were to take that host and go to look at its related objects and go to data stores, I can see now that I've got the generic data store that was created when the OS was installed, and now I've got my direct attached storage, and those show up right here. You know, one's 32 gigs, one's 511 gigs. That's the storage that's available. For now on, when I create a virtual machine, I can specify this data store, and that's where it's going to reside. Now know that when I mapped this, I mapped it to an internal disk, but I could have mapped it to a LUN, and this could exist on a SAN. And that means I could go to other servers, and it could exist there too, right? If they're connected to the SAN, they can see that disk and have access to that data store. That's where clustering comes in, which we'll see in another episode. All right, now let's talk a little bit more about SANs. A lot of times when you have a SAN connected, the disks just show up as local disks. But there's one exception to that. If it's a fiber channel SAN, that's how it is. They're going to show up that way. When you go into your host, so if I take ESX host 01 and I go to manage and storage adapters, under storage adapters, I would have a fiber channel HBA that would show up in here as an adapter. And when I went to devices, I would see the hard drives that the SAN was advertising to me, and they would just show up as local disks. That's how a fiber channel SAN works. They're really straightforward. In fact, the only configuration you ever really have to do on the ESX side, there's a lot on the SAN side, but on the ESX side is if your adapter is not automatically detected. You might need to go to storage adapters and hit your little plus here and add in a missing adapter. But when you use an adapter, it should be on VMware's compatibility list, the HCL. And if it's on the hardware compatibility list, it'll be detected and it'll show up right here. If it doesn't, you're probably using an adapter that VMware's not going to support anyway. So definitely get one that is supported. But there are certain types of adapters that don't show up automatically, the software ones. And when I hit that plus, you saw them right there, a software iSCSI adapter and a software FCOE adapter. All right, what are these? Well, software FCOE, that is fiber channel over Ethernet. And that's where instead of having fiber channel running right to a SAN here, we do fiber channel to an Ethernet adapter. All right, and why would I do that? Well, normally when we have fiber channel run, it's to a SAN right there in the same building as our device. But what if this is a disaster recovery center and the SAN is at our headquarters and this host is at the DR center? They're in two different geographic locations. I may not be able to run fiber between those locations. So instead, I can use fiber channel over Ethernet. And now I can take the fiber channel communications and send them over an Ethernet network over a VPN tunnel to a remote location or MPLS or whatever it is that I'm using to connect to that remote location and have connectivity even though I'm not in the same building as the SAN. Now that sounds awesome, but remember, Ethernet networks introduce overhead, a lot of overhead. On a true fiber channel SAN, the fiber fabric, right, that mesh that you create between your servers and the SAN, it's actually just running the SCSI protocol right on top of that fiber. It's modified just a little bit, but for the most part, it is just SCSI communications right over the fiber. Here, we've got to take SCSI and then encapsulate it in Ethernet and TCP/IP and throw it on the network. So now we get all the TCP/IP overhead, and we get collisions and what is it? CDMA? It's CSM. What is it?
Collision sense carrier. Collision sense. Now I can't even say it myself. Carrier sense multiple access collision detection.
There we go. Oh, CSMA CD. That's it. That's the acronym. And so we've got all that extra stuff that Ethernet does that slows the communication down. The SCSI doesn't normally have to do. So it's not fast. So if I just need a remote location able to see this data store to be able to clone VMs or something like that, then it'll do it, but it's not something I'd want to run on for production use. It's more of a disaster solution, right? The other one, though, is a software iSCSI adapter. iSCSI is very similar. We're taking SCSI and throwing it over Ethernet. And where this is handy is if you don't have a giant budget, right? A fiber channel SAN is not cheap. The cheapest ones you can deploy today are usually in the $30,000 to $40,000 mark, and that's just for the SAN. You probably have a switch on top of that, so you probably end up closer to $50,000 for your basic fiber channel SAN. Well, you can do an iSCSI SAN for $3,000, $5,000. You can do them pretty inexpensive. They're slower because they're using your regular TCP/IP network, but if you do a dedicated network and you do jumbo frames, right, where you have a 9,000 byte MTU instead of the old 1,500 byte, then you can actually get pretty decent performance on it. It's great for labs and testing, small businesses, medium and large, it's time to go fiber channel, right? But for a small business, you can get by with iSCSI and it works out well. The thing about iSCSI is it doesn't have a dedicated hardware adapter. So we've got to add in a software one, and that's what this is offering for me to do. So I'm going to add one in here. I'll add a software iSCSI adapter. And when you add an iSCSI adapter, what it's going to do is enable you to look to the network for storage. And because it's attached to the network, we can't automatically find things. We have to tell it where the things are. So I'm going to come in here and find my fiber channel adapter, which is not showing up. If it doesn't show up, you might need to refresh. And you'll see with storage, we have to refresh all the time. So you'll see a button right here to refresh storage information, to refresh our control adapters, and so on. So you may need to refresh to get that thing to show up. Or sometimes you just have to be patient and it'll turn up that way too. So I'm going to let this thing scan. I'm going to pull up my recent tasks here and just see. We've got that rescan of HBAs going on, so it should be there as soon as it shows up. If it still doesn't show up, I may just need to refresh my whole screen. And, oh, there it is. All right, just got to be patient. So there's my iSCSI adapter, and if I choose that, it's VM-HBA33. Right down here, I can see devices that are plugged into it. Now, if it were a fiber channel SAN, I'd immediately see disks, right? Because we view it as a hard drive controller. But with iSCSI, I don't. I've got to talk to the iSCSI appliance. It's on the network, so anybody can connect. You don't want just anybody being able to get at the data. So we have to have a user and a password, or do IP restrictions, or whatever. So I need to go over here to targets. The target is the iSCSI SAN itself. And I'm going to do dynamic discovery of that target, and I'm going to add it in. So I need to add in 192.168.0.204. That's my iSCSI SAN. Okay. Now, if you're just doing IP restrictions, that's all you need and you can move forward. If you're doing authentication, though, like I am, then I'll need to provide a username and a password. So I'm going to come down here, and iSCSI SANs use CHAP, the Challenge Handshake and Authentication Protocol. And so I'm going to do unidirectional CHAP. That's where I send a username and a password. You can do bidirectional, where they send a username and a password back to you. You can authenticate both ways, but I'm just going to send to them. And I'll provide a login. And this will be configured on your iSCSI SAN. So whatever is set over there is what your credentials are going to be. So I'm going to punch that in. I'll go ahead and say OK to that. And it's telling me, due to recent changes, we need to rescan the storage adapter. And so right up here, I've got the rescan for storage adapter button. And I'll go ahead and highlight my iSCSI, hit rescan, and now it's going to scan it. And when it scans it, it's going to talk to that iSCSI appliance and hopefully learn about some disks. And so now when I go down here to devices, what I'm hoping to see, there we go, is I got a 1 terabyte drive right there. So there's a 1 terabyte drive attached to that iSCSI SAN that I now see and I can use. And because it's iSCSI, we don't know if it's a regular magnetic disk or if it's SSD. So I've got that same button right here where I can change its status and flip it to flash or HDD or whatever. But now that it's attached, my system will see it as a local drive. I had to go through a little work, but I see it and I can see it as a local drive. So when I go back to my host, I can go to storage and new data store, and I'm going to create another data store. I'm going to do VMFS just like last time, Except this time, when I look at my disks, there's that iSCSI SAN right there. Okay, I can see it and I can choose it, and I can come in and give it a name. I'll call it ESXhost01 iSCSI Data Store, so I can remember that's what it is, right? Just kind of giving it a name that actually means something. I can move forward and finish that up, and I have a whole terabyte on this thing, so I could take the whole thing or I could partition it down. Again, not a lot of point in partitioning it down, so I'll take the whole thing and we'll finish that up. Now that it's done, as soon as that's completed, I can go to my related objects and my data stores, and what I'm going to see is my direct attached storage data store and my iSCSI data store right here. And from that point on, we use them the same way. It doesn't matter that one's on the network versus one is direct attached. We actually treat them the same way. The big advantage of the iSCSI one is that I can have other servers connect to it, right? There's two big advantages for having a SAN, be it iSCSI or Fiber Channel. The two big advantages: one, you can have more than one host connect to it, which enables clustering. Now, I can take a virtual machine and fail it over from one host to another because both hosts have access to the hard drives. All I have to do is synchronize RAM. If I shut the virtual machine down first, I don't even have to synchronize RAM. I can move it over instantly because the storage is already visible to the other server. That's the first advantage. The second advantage is because it's on the network like this, it is easier for me to expand and modify and change permissions, where we can have it survive longer. We're going to get better utilization out of it than it would if it was kind of stuck inside of a single box. So now we get that expandability, the ability to grow and exceed what the storage is inside of a single server. So we're no longer dependent on that physical server anymore. It's out here on the network. The trade-off is, well, with iSCSI, it's performance. With Fiber Channel SAN, there's really not a trade-off. Fiber Channel SANs give you a huge amount of bandwidth. You can have 6 gigabit drives and 8 gigabit fiber channel. And so now your fiber channel is able to move more than what a single drive could do. Now, if you're doing multi-drive communications, we do end up with a bottleneck. All right. You know, let me throw in a third advantage. A third advantage for having a SAN is multi-path. With direct attached storage, you have a SCSI or a SATA cable that runs from your motherboard to the drive, right? There's only one way to get to that drive. But when it's on the network, I could have 2 fiber channel HBAs that ran to 2 different fiber channel switches that ran to 2 different ports on the SAN. Or I could have 2 different network adapters with iSCSI that run to 2 different switches that run to 2 different ports on the SAN. I can have multi-path. When you have multi-path, you can load balance and increase your bandwidth, or you can use one, and if it fails, you can jump over to the others. Now you get redundancy built into it. That's another advantage of having a storage area network that you don't get with direct attached storage. So there's a few different kind of bells and whistles available with that. But once they're created, you use them the same. If I were to whip up a virtual machine, right? Let me come in here and whip up a virtual machine real quick. So I'm going to create a new virtual machine. And when I go to create the virtual machine, it's going to ask me a series of questions. I'm just going to enter in junk here because I want to get down to the storage screen is where I really want to be. So I'm going to create a virtual machine on ESXhost01. And on the storage screen, it asks me where I want to put my virtual machine's disks. And I see all the data stores here. And had I not named it as the iSCSI data store or the direct attached storage or the fiber channel storage, if I don't name them, you don't see a difference. They all have the same icon. They all say VMFS version 5. They all support storage DRS. They all work the same. So once they're created, they're super easy to use, right? So don't shy away from going with the complex storage solution because, yeah, it'll be complex to set it up in the beginning, but once it's in place, use it just like anything else and it becomes easy. You know, I threw out storage DRS just kind of offhanded there. I don't think we've talked about that yet. DRS is Distributed Resource Scheduler. We're going to see it in a later episode, but it's a really cool feature that's a part of the vSphere Enterprise Plus, and I think it's also packaged with the operations management. And what it lets you do is monitor performance on your systems. And if there's an excessive amount of disk I/O on one data store, it can actually take a virtual machine's disks and move them over to another data store where there's more disk I/O available. So it can balance things out based on resource utilization. It's really awesome. It's kind of neat. It's very powerful. You'll get the best performance possible out of your system if you have it, hands down. But it's a little bit weird because you'll come into work in the morning and you're like, I want to look at this virtual machine and I wonder where it is today. I wonder where its disks are. Is disks over here? Are they over there? Are they over there? I don't know. And the reality is we have the Related Objects tab, and you can go there and you can figure out where stuff is really fast. So it's not that big of a deal, but it's just kind of, it's one of those hard things to get used to is hey, I'm getting the best performance, I'm getting the best redundancy, but I don't really know where this stuff is landing, where it's sitting, so it kind of makes it a little bit weird. But that's what the storage DRS is, and it doesn't just apply to storage. We have it for CPU, memory, and all the other ones too. It's just IC storage right here. So I could come in and I could choose my iSCSI storage, and now when I move forward to create this virtual machine, it's going to whip it up, and its hard drives will exist on that data store. And so they'll sit there, and I can put other things in the data store. I'll show an example. I'm kind of out of time on this episode, but in the next episode, I'll show you guys how you can stick ISOs in the data store. And now anytime you need a CD image popped into a virtual machine, you can just go and grab it. For example, this one, if I want to install an operating system on it, I'm going to have to get the operating system from somewhere. So it'd be nice if I had the ISOs in some kind of centralized location that everybody could get to, right? So those are some of the things that we can do when we have a network-based data store that you can't really do with direct attached storage. So definitely a big difference there. And I'll just cancel this VM. But I'll leave that data store there because we're going to see it more in our later episodes.
All right, Don, a lot of great information setting up the storage, and then I know that we've got a lot more to go, but looking at that time clock, like you mentioned, does look like we're approaching the end of another episode. But before we sign off, do you got any additional words?
I do have a lot more to talk about on this, so we're going to do a part 2. I want to talk about NFS stores. They don't get used a whole heck of a lot in real life land, but for whatever reason, they always show up on the exam, which is kind of annoying. But I'll show you how NFS stores work. I didn't show you guys Fiber Channel, but know that with Fiber Channel, it is exactly like direct attached storage. All the real work is done on the SAN. On the SAN, you got to slice up the disks, and on the SAN, you've got to say these disks get these LUNs, and these LUNs get assigned to this HBA's identifier, or worldwide name for that adapter. When all that's set up on the SAN, you fire up your ESX box and it just sees the disks, and that's it. I mean, there's not really much we do here. So on the exam, they want you to be familiar with Fiber Channel, but there is no configuration for it because it's not a part of ESX. The configuration is done on the SAN, and at least so far, VMware doesn't make any SANs, so we don't have to worry about it there. But those are the key things. I feel like there was something else I wanted to talk about. I'm going to save distributed storage for when we get to the clustering section. That's a great chance for us to see distributed storage and how that works. Although, kind of already see it here with iSCSI, is I can go and add that iSCSI target to other hosts and get that distributed storage. So we'll get a chance to see that later on.
All right, Don, always a pleasure to have you here in the studios, and always a pleasure to have you, the viewer, joining us. Signing out for IT Pro TV, I've been your host, Wes Bryan.
And I'm Don Pizzette.
And we'll see you next time.